So we'll start with the first drug, which is heparin, a large polysaccharide polymer, usually taken from animal sources. It has a small size. It has a large size with an average molecular weight of 15 to 20,000 daltons, and it's highly acidic. But the good thing is it can be neutralized by molecules such as protamine, which is basic. Basic means alkaline. So it's given intravenously or subcutaneously to avoid the risk of hematoma associated with intramuscular injections. So this is what you get if you give it intramuscularly instead of subcutaneously or intravenously. You might get this hematoma formation. So this is a picture of a heparin injection vial. So this is something where you can use multiple times. It's a multi-dose vial. And so here it's mentioned again for subcutaneous or intravenous use. So this is just a little bit on the heparin manufacturing process. So previously it used to be in the US, there was a stage when there was only heparin which is from porcine origin, and there were none from bovine or none from the cow. Okay, so everything was taken from the pig. So previously they took it from the intestines of the pig, okay, collected from the slaughterhouses, and they extracted the mucosa, and they digested the mucosa with enzymes, and then they separate the polysaccharide material and complex it with resins or ammonium salts. So this is how they concentrate the heparin, and then they release the crude heparin from the resins, and precipitation of heparin with water miscible organic solvents. So what they removed was they removed neutral and positively charged impurities, peptides, DNA impurities, and lipids, okay, through this process of separation. This is not very important to know. This is just for the sake of knowing. This is taken from the FDA website, I think. So next, it undergoes purification. So you do the acid and base wash to inactivate the virus. Okay, and then you have hydrogen peroxide, potassium permanganate, or peracetic treatment. So which is part of the chemical oxidation and viral inactivation step. And then we have the alcohol or water precipitation, and then multiple refractionation, and also after that drying. And in this stage, we again remove DNA impurities, and besides that, we remove protein, we remove viruses, bacterial endotoxins, and glycosaminoglycans. So all of this they are done to reduce the impurities and hopefully reduce the incidence of allergies, etc. There's another picture showing the timeline of therapeutic heparin in the US from a historical point of view. So previously it started with dog liver, taken from the dog liver, 1916, and then from the lungs of cows, and then from the cow's liver, okay, and then Finally, in 1942, we had both bovine and porcine heparins in the US. And then suddenly it was withdrawn, okay, from the market. And then there was an issue with heparin adulteration. So there was some complaints, and there were reports of saying that the heparin was not pure. Okay, it has adulterated. Okay, so then there were issues, and then in year 2014, so the FDA reintroduced bovine heparin to the market in the US. Okay, so in other countries it's a bit different. So you can find, I think you'll be able to find in most countries bovine and also porcine heparin. So in Muslim countries, probably you'll just have mainly bovine heparin, whereas in other countries you might have both bovine and porcine heparin. So why did suddenly they stopped using bovine heparin in the US? Mainly concerned with the BSE and also the Creutzfeldt-Jakob disease, okay, in the 90s. So they were afraid that the virus might be infectious to humans, okay, from taking the heparin from the cows. So beside the standard heparin, we have the low molecular weight fractions of heparin. Example, enoxaparin, deltaparin, tinzaparin. So it has a molecular weight of 2 to 6,000 daltons, and it has a greater bioavailability, okay, and longer duration of action compared to the unfractioned heparin. Okay, compared to the standard heparin, it has a longer duration of action. Thus, doses can be given. What is the answer to this? Is it more frequently or less frequently? So of course it is less frequently, because the longer duration of action, the longer half-life, means you can dose it less frequently. So this is also given subcutaneously. So what is the mechanism of giving heparin? What's the effects? What are the effects of heparin? So the unfractionated heparin binds to endogenous antithrombin 3. Okay, binds to the endogenous antithrombin 3 via a saccharide sequence. So binds to antithrombin 3. Heparin binds to the antithrombin 3. This heparin is here. Okay, this is the antithrombin 3. And the heparin antithrombin 3 complex combines with and inactivates thrombin and other factors, especially factor 10A, irreversibly. So it combines with thrombin and then inactivate it. Okay, and then also it inactivates other factors like factor 10A. Okay, so the antithrombin 3 and heparin complex, okay, binds to factor 12A, 11A, 9A. So these are all from the APTT pathway. Okay, the APTT pathway, or the intrinsic pathway. Okay, and then we have the factor 10A, factor 2A. which is prothrombin. So we have heparin binding to the antithrombin 3. Okay, so it becomes nicer. It enhances the binding or the action of antithrombin 3. Okay, compared to without heparin, you can see that it's trying to, in this simple diagram, it's trying to show that it's not really fitting nicely. Okay, so it doesn't really work very efficiently compared to when you have heparin. So it really works. Okay, so you have the antithrombin 3, so causing dissociation of, after that you have dissociation of heparin, but before that, of course, you have the anticlotting effects. There's another diagram, so showing the same thing: heparin, antithrombin 3, with the unfractionated heparin binds to the thrombin, and also it affects other things like factor 10A, activated factor 10. Okay, can bind there. So the antithrombin 3 proteolyzes, okay, it lyses the thrombin and factor 10A 1,000 times faster with the presence of heparin. So when you have heparin around, as I mentioned previously, so the proteolization is faster compared to without heparin. So heparin provides immediate, instant stat anticoagulation after dosing due to its action on preformed blood components. So for monitoring of the action of heparin, you have to monitor the APTT, okay, activated partial thromboplastin time. Why? That's obvious from this picture. So this is 12, factor 12, factor 11, factor 9, 2, 12, 11, 9. So these are all from the APTT pathway, so the longer pathway. So you have to monitor the APTT. And then the low molecular weight heparin and fondaparinux, it acts like heparin, okay, it acts like the unfractionated heparin, but it's more selective and have no effect on thrombin. So, but the issue with the low molecular weight heparin is that they are not reliably monitored by APTT, which is an issue in renal failures, because you need to monitor. Okay, you want to know how are they going on. Okay, indications for heparin, deep venous thrombosis, this pulmonary embolism, acute myocardial infarction. Okay, heparin does not cross the placental barrier, and it's used together with thrombolytics, okay, like streptokinase and all the other drugs that are thrombolytics for revascularization, and also used with glycoprotein 2b3A blockers during angioplasty and stenting. Adverse effects are bleeding. Okay, protamine lessens. Okay, we know that this is a base, lessens the risk of serous bleeding, which can lead to stroke, hemorrhagic stroke. And then we might have transient thrombocytopenia. In an unfortunate condition, you might get severe thrombocytopenia. So this is very unfortunate. You have this thrombosis and also osteoporosis with chronic use. And you are less likely to get severe thrombocytopenia and thrombosis with lower molecular weight heparin and fondaparinux. Okay, that's all for this segment. We'll continue in the next video.